So today we're going to be solving for systems of linear equations. So the first problem is the admissions fee at the Headworth Fair is $1.50 for children and $4 for adults. And on the day of the fair, 2,200 people enter the fair and $5,050 is collected. How many children and how many adults attend? For word problems, we first need to define our variables. So we have $1.50 for children and $4 for adults. And then we have to say that on the day of the fair, 2,200 people came and $5,050 were collected. And this is what we need to solve for. So now we have to redefine our variables. So we can do y equals the $1.50 for the child fee, and x can equal the $4 fee for an adult. And on the day of the fair, 2,200 people attended, so $5,050 were collected. And so we can write the equation for this. We can write that x, the number of adults that attended, plus y, the number of children that attended, equals 2,200 people. And so we can write 4x, so $4 times the amount of adults that attended, plus 1.5y, the cost for children, times the amount of children that came, equals $550, which is the total amount of money that was collected. So now we're going to solve for y, and in order to do this, we have to find the value of x. So the value for x is just y subtracted from 2,200. So that means we can just do 4 times 220 minus y is equal to, plus 1.5y is equal to 5,050. So now what we have to do is we have to distribute the 4. So we have 880 minus 4y plus 1.5y equals 550. And then we can add these two together. So now that we're going to add them, right? So that would bring us with 8,800 minus 2.5y equals 5,550, right? So now we're going to add these two together. So that would bring us with 8,800 minus 2.5y equals 550. So then we subtract the 8,800 from each side of the equation to get negative 2.5y equals negative 3750. And so we divide each side by negative 2.5, and then these two cancel each other out. So then we have y equals 1,500. So going back to our original equation up here, we can then substitute y for 1,500, and then subtract 1,500 from each side, and that would give us x equals 700. So now we have the child value, which means that 1,500 children came, and then 700 adults came.
A train leaves the city at 2 p.m. A second train leaves the city at 8 p.m. and follows the first train. The second train's speed is 162 miles per hour faster than the first train's. If the second train overtakes the first train at 10 p.m., what are the speeds of the trains? First, we need to define our variables. We're going to let x equal the speed of the first train, and we're going to let x plus 162, since the second train is 162 miles per hour faster than the first train speed, be the speed of the second train. Now, let's create a table. Okay. So we have train 1, and we have train 2. Now, let's put the time, and then we'll have this one be speed, this one, the final product will be distance.
So the club is actually gradually building.
And we know that time times speed is equal to distance. So for the first train, it leaves at 8 p.m. and its speed is x. And it goes, so we're going to do 8 times x, and we'll 8x. For train 2, it leaves at 2 p.m. times the speed x plus 162. And we'll get 2 times x plus 62. Okay. Now we have both of our equations. So what we know is that when the second train overtakes the first train, they must be traveling the same distance. Because of this, we are going to rewrite both of our equations and make them equal to each other. So we're going to have 8x is equal to 2x, to 2 times x is 162. So we get 8x, distribute the 2, 2x plus 324. Now we're going to subtract 2 from this side. Get 6x is equal to 324. And now we're going to divide both sides by 6, and x equals 54. So now we've solved one of our equations. We know now that the first train, its speed is 54 miles per hour, which is first train.
Rob took so
And
long,
now,
he actually
since
said
we know
yes.
the value of
He said
x,
yes over Christmas
we can
break.
plug
And it just
54 into our equation for the second train. The equation for the second train is x plus 162.
They come in every Wednesday, and then this week they've been in every day.
So we plug in x,
And more and more kids are going
54
back, ninth graders, which is cool.
plus 162,
So Kerry Horsey's son,
and we get
what do they need?
216
They're making
miles
a cube
per hour for the second